Hi, I'm Dave Phelps of ICF Homes. I'd like to welcome you to another episode of our Whiteboard series. Today I will talk about good HVAC design and convection in a house. In our illustration we show a typical two-story house with a basement. In this series we show each level of the house, second floor, first floor, basement, has its own thermostat. It's tied back into the heat pump. Each of the thermostats are smart thermostats, meaning they can talk to each other. As each level of the house needs specific heating or cooling, they will then send that signal back to the heat pump, and the heat pump will move the air along. But one of the really neat features about good HVAC design is to use our steady basement temperature and get that steady basement temperature all the way up to the second floor of the house. Because all the energy that requires is just the fan of the heat pump itself to move the air from the basement all the way up. And the way we do that is a zone system. So for example, if the second level of the house in the summertime, we've got a 90-degree day outside, and we're trying to maintain 70 degrees inside, it's going to heat up on the second floor of the house. But we've got our steady basement temperature, which by use of the steady ground temperature of, we say, 55 degrees, the steady basement temperature, the air from the fan running on the heat pump will pull air in low in the basement, and it'll pull it into the system. And because the basement doesn't need cooling and the first floor doesn't need cooling, the dampers here are closed. This damper up top opens up and it blows out the air from the basement that moved all the way up to the top of the house. It was already nice and cool up to the top, and it helped to cool the second floor of the house. If the first floor needs cooling, the same thing happens. This damper opens up and we blow cool air out. The whole goal is to move the air from the basement all the way up to the top of the house and back down, up and down. That's really good convection in a home. Movement of the air around keeps the air very, very fresh and moving around. This is also the only energy this requires is just the fan of the heat pump. If for some reason we need more cooling up top, the heat pump turns on, these dampers close, and it blows out cool air at the top. And that is how we actually use our steady ground temperature as a geothermal house, and we move the air throughout, and it is just a fraction of the energy to heat and cool a home if you utilize free energy. Most homes today, they do not have a zone system. There's no damper here, and there's no damper here. The ductwork ends here. You only have one thermostat on the first floor of the house. You have another thermostat on the second floor, but you have your heat pump up in the attic. And this thermostat doesn't go down, and actually the control goes up to the heat pump. Now, if the first floor needs cooling, it blows cool air out here, but it also blows cool air into the basement. The basement never needed, and that's why many homes, the basements feel so cool in the summertime, and or maybe sometimes think cold, is we're getting cold air from the heat pump. It doesn't need it, because the first floor needed cooling, the basement didn't need it, but most homes, the way they're designed, cold air blows out in both areas. The other challenge is on the second floor, you've got your heat pump up here in the attic. It could be 140 degrees in the summertime, and your heat pump is a 140 degree metal box, and you're trying to blow 70 degree air out from a 140 degree metal box. They do it, it can be done. It takes an awful lot of energy to get air from 140 down to 70. That's the way a lot of homes are, but it's just not the most efficient way to do it. This zone system, moving the air around throughout the house, it can be done whether it's a conventional wood-framed house or an ICF home. Thank you for your time. More to come. Have a good day.